Hi, welcome to Elementary Statistics. Today we're going to be talking about frequency distributions. So here is a definition of a frequency distribution. However, it's just a fancy table. That's what it is, or an organized table. That's how I like to think of it as organized table. For example, here is a simple listing of data. So here we have ages of students, let's say. Um, Data by itself, if you just look at it, it's not organized. It's hard to pick things out or make some observations. So we need a better way to organize it. So one way is to use a frequency distribution. So all that is it's taking the ages and is creating intervals of ages. They're grouping them together. So for example, 15 to 18, you have 24 students. So if you count these, this isn't the full list, but if you have 24 students between 15 and 18, and then between 19 and 22 you have 46, and so on. This is what a frequency distribution is. So in this video, what we're going to do is we're just going to look at the different parts of a frequency distribution. Another important thing to note is if you want to figure out the total number of people or students in this case in the sample, you can add up all of the frequencies and that would give you your total. So just kind of keep that in mind. All right, so same table. The first thing you need to know is that the groups that we've broken them up to, we refer to them as classes. So in this problem, in this frequency distribution, there are 4 classes. And the lower numbers in each of the class we refer to as the lower class boundaries, or I'm sorry, lower class limits. So that they are the smallest numbers that can actually belong to different classes. And the larger numbers in each of the class, the largest number is referred to as the upper class limits. And then we have class boundaries. So the way you think about class boundaries is that they're the separators of the classes. So for example, let's retry that. So for example, one of the class boundaries is right here because it separates the first and second class. Another one is here. Another one is here. But we have 2 more that we have to consider as well. Namely, we need the one that separates the beginning of the class and the one that separates the ending of the class. So in this case, for example, let's look at the second one. The boundary that separates the first class and the second class is a number that is in between 18 and 19. So the number that is in between the upper class limit of this first class and the lower class limit of the second class. So between 18 and 19, we have 18.5. This class boundary is the number that is between 22 and 23, and that would be 22.5. This class boundary is a number between 26 and 27, which is 26.5. So again, it's the number that's between the upper class limit for this class and the lower class limit of this class. This number separates these 2 classes, if that makes sense. All right, so again, we also need the one that starts it off and the one that caps it off. So in that fashion, the number before 15 would be 14.5. And then the number that caps it off is 30.5. Since this is the largest age in this case, 30.5 is the last class boundary. All right, so let's keep going. And then we have class midpoints. So class midpoints are the midpoints of each of the class. So for example, the first class midpoint is the one that is in the middle of 15 and 18. So the class midpoint of the first class is, here's a formula to help you guys figure it out if you can't just see it. It's upper plus lower divided by 2. So pretty much we're taking the average of the endpoints. So in this case, we're taking 15 plus 18 and we're dividing it by 2. So the first class midpoint is 15 plus 18 divided by 2. So if you work that out, you'd get 16.5. So this would be 16.5. And then the next class midpoint, which is the midpoint of the second class, is 20.5. The third one is 24.5, which is the midpoint of this class. And the last one is 28.5, which is the midpoint of the last class. And again, for example, if you want to use the formula to get the 28.5, you'd add 27 plus 30 and then divide it by 2. So pretty much you're taking the average of the endpoints. Okay, and then we have class width. So class width is found by taking the difference between two consecutive lower class limits. So it's eventually we're going to graph these, and the one way you can think of it is each of these is going to be a bar when we graph it, and it's how fat the bars are. So to find the class width, we can take any of the consecutive lower class limits. For example, if we take 23 and 19, which are consecutive, right? They're consecutive lower class limits. 23 subtract 19, we'd get 4, right? So if we continue in that fashion, we should always get the same class width no matter which two consecutive lower class limits we take the difference of. So for example, 19 minus 15, which are the difference between lower class limits, right? Consecutive lower class limits, you get 4. 23 minus 19 is 4. 27 subtract 23 is 4. All right, so class width. So eventually where we're going with this is we're going to take this frequency distribution and we're going to plot it on something we called a histogram. So just real quick here. So very often the numbers that we display here are the class boundaries. In other books, they may use the lower class limits. So it's not consistent. Even in this book, sometimes we see that they use the lower class limit as well. So I just kind of want to give you guys a preview of this. In this graph, sorry, let's try it again. This graph we refer to as a histogram, or we call it a histogram. Okay, and then frequency distributions can be also used for categorical and quantitative. So for example, here we have the classes are the ethnicity or race, and then the frequencies right there. All right, so let's get a little practice with this, figuring out all this stuff. So this question, we have a frequency distribution for IQ scores, and then we want to figure out all of these stuff. Okay, so first question asks, what are the lower class limits? So in this case, lower class limits are the lowest number in each of the class. So these are the lower class limits. So we have 50, 70, 90, 110, 130, right? Oops. And then the second question asks, what are the upper class limits? So upper class limits are the largest numbers in each of the class. So in this case, we have 69, 89, 109, 129, and 149. Right. And then the next question asks, what is a class width? And if you guys remember, class width is the difference between two consecutive lower class limits. So in this case, we can choose any consecutive lower class limits. So for example, we can choose 90 and 70, or we can choose like 110 and 90. So it doesn't matter. So let's see, 90 minus 70 gives us 20, so the class width is 20. So question after that, class boundaries. So again, the first class boundary is the one that is right before the first class, and then this one, and then this one, and then this one, and then this one, and then the last one. All right, so the one right before 50, we have 49.5, so let's write that there, 49.5. And then the one between the two classes here is the number between 69 and 70, so that'd be 69.5. And then the next one would be, let's see, 89, between 89 and 90, that'd be 89.5. And then the next one would be 109, between 109 and 110, which would be 109.5. And then between 129 and 130, that'd be 129.5. And the last one, let's see, 149 is the largest or the upper class limit of the last class, so we'd have the last one being 149.5. All right, and then the class midpoints. Class midpoints are the midpoint of each of the class. So, and that can be found by taking the average or the mean of the lower class and upper class limits. So if you work that out, so for example, for the first one, it's going to be 50 plus 69 divided by 2. If you work that out, you should get 59.5, and then continue in that fashion. So taking 89 plus 70, dividing by 2, you'd get 79.5, and then 99.5 is the next one. And then for the fourth class, the fourth class midpoint would be 119.5, and then the last class midpoint would be 139.5. All right, so hopefully that makes sense. And then the last question says, how many total IQ scores were obtained in this sample? So hopefully you guys remember how to figure that out. So the total number of IQ scores is found by adding up all of these frequencies. So if you add up 2 plus 33 plus 35 plus 7 plus 1, you should get 78. All right. So that is what a frequency distribution is. You got to know the different parts. We also have something called a relative frequency distribution. And all that is this is a frequency distribution for categorical, but we can change it into percentages. That's all. That's what a relative frequency distribution is we're just changing the numbers. Instead of having 350, we're changing it to 11.4%. And then we're doing the same with all the other frequencies to get the total. We're just representing them as percentages. Sometimes instead of percentages, we're going to represent them as decimals. So just kind of be prepared for that. Relative frequency distribution. And then the formula for figuring out each of the percentages or decimals, if we're figuring out the decimals, proportions instead of percentage. Sometimes we're going to be using proportions, which we represent with decimals, and sometimes we're going to be using percentages. These are the formulas here. So the difference between these two formulas, when you change it to a percentage, all you're doing is taking this same fraction and you're multiplying it by 100%. So hopefully that made sense. If you have any questions, feel free to let me know.